In this video, I'll be covering the quadratic formula and the discriminant. So quadratic formula. This requires us to remember what the quadratic formula is. When we use the quadratic formula, we are using it to find the zeros of a quadratic function. The quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So that's prerequisite. We need to know what the quadratic formula is. So if you read the instructions, it says find the discriminant of each quadratic equation. Well, please remember that a quadratic equation we know is quadratic when the highest degree is 2. So because we have the term x squared and that's our highest degree, then we know it's a quadratic equation. It says to use the discriminant of the quadratic equation and then use it to find it and then use it to determine the number and nature of roots and then solve it. So when we take a look at this, we first need to understand what the discriminant is. The discriminant is actually the value, I'll put over here, d equals b squared minus 4ac. So basically, it's the radicand, meaning the number that's under the radical. In order to find the discriminant, we need to be able to identify a, b, and c. So keep in mind that a quadratic equation is of the form ax squared plus bx plus c equals 0. So it has to be in that form in order to work with it. Because we already have this equation in that form, we can go ahead and identify a, b, and c. We have an a value of an understood 1, b value of 6, and a c value of 4. Well, the discriminant is going to tell us some pretty interesting things about the number and nature of the roots. Please recall that in your previous math courses, you've learned about 3 possibilities when solving a quadratic equation. You can have 2 real solutions, meaning you've got 2 x-intercepts. You could have 1 real solution. And in Math 2, you learned that if it does not touch the x-axis, then you have no real solutions. Well, all of these things can be determined by the value of our discriminant. And what's different in this course in Math 3 than Math 2 is you're actually going to learn that if you have no real roots, you actually have 2 imaginary roots. And you're going to find those using the quadratic formula as well. But now you have the skill since we've covered imaginary numbers. So to find our discriminant, place everything in parentheses. We're simply substituting our values here. Our b squared minus 4 times our a value times our c value. And then we always want to just type it in our calculator. No sense in getting it wrong. So, 6 squared minus 4 times 1 times 4 is 20. So I'm going to write down 20. So if we actually graph this thing, we'll get to see what connection it has to, our discriminant value has to the graph. So if I type in x squared plus 6x plus 4, and I look at the graph, I can see it crosses 2 times. So I have 2 real roots. Roots or x-intercepts or solutions, okay? So what we've figured out so far is if our discriminant is greater than 0, we're always going to have 2 real, okay? To finish and find our solution, which remember is your x-intercepts when graphed, we use our quadratic formula. But remember that we already know the value of b squared minus 4ac, so we do not have to plug that in again. So we go ahead and type in the opposite, or write down the opposite of b. So if b is 6, the opposite of that would be negative 6, plus or minus the square root of, we already know the value of b squared minus 4ac. We already know it's 20, all over 2 times our a value, which is 1. From there, we continue to simplify. And remember that when breaking down the square root of 20, we use like a factor tree. And so that would be 2 square roots of 5, all over 2. Well, we're almost through, but we are not through until we simplify, if possible, by considering the 3 numbers here on the outside. So not the irrational number, but the 6, 2, and 2. If we can find a common factor to reduce, we have to do that. And all of these are divisible by 2. 2 goes into 6 3 times, into 2 once, and 2 ones. So that means for our final answer, we'll have 3 plus or minus the square root of 5. We do not need to put it over an understood 1, since if we divide by 1, we just get the numerator. Okay? So that's the first case. That's when we have a discriminant value greater than 0. If we take a look at the second one, then we go ahead and write out our A value, our B value, and our C value, and then substitute into b squared minus 4ac to find the discriminant. Our b is negative 3. Those parentheses are really important there. So b squared minus 4 times 2 times 2. If we plug that in our calculator, we get a negative 7. So my discriminant value is negative 7. So when I see your work, I need to see that you plugged it in and also the value. Well, if we look at the graph of this one, we got a negative discriminant this time. So let's see what that means when we get a negative discriminant. We actually see that it does not cross the x-axis or touch it at all. So that means we have 2 imaginary roots. 2 imaginary roots. So that should make sense, because as we go to solve this thing using our quadratic formula, and we have x equals the opposite of b plus or minus the square root of our discriminant all over 2 times a, then we should go, oh yeah, we've got the square root of a negative, which means we'll have I. And at this point, we're done. This is our answer. Okay? So if we take a look at the third problem here, we notice that it is not yet in standard form because our linear term isn't in the right place. So let's move it over. And I highly recommend, by the way, always moving the terms to ensure a quadratic term that's positive. I would never move the 9x squared over here and then have to deal with negative 9x squared. It just makes it easier to always keep your quadratic term positive, even when you need to move 2 terms. So we now have 9x squared plus 24x, oops, because we have to add 24x to both sides. That's why it turns positive. Okay? And then identify our a, b, and c. And then substitute into the discriminant. If you feel like I'm going too fast, just feel free to pause it, please. So b squared minus 4 times a times c. I'm going to type that in. 24 squared minus 4 times 9 times 16. And I get 0. Well, that's different. So let's see what happens when we graph this one. We've got 9x squared plus 24x plus 16. Oh, this is the third case. This is where it touches the x-axis one time. Okay? So that means we have one real repeated root. It's going to be repeated because it kind of counts as twice. It means the quantity squared. Remember, I was talking about the multiplicity and it bouncing off the x-axis. So to finish solving this, we would have x equals the opposite of b plus or minus the square root of 0 all over 2a. Well, if I continue to simplify that, the square root of 0 is 0, negative 24 plus 0 is negative 24, and negative 24 minus 0 is still negative 24. So it's really just negative 24 over 18. You do reduce that. Here you can just type it in and hit math enter, enter, or you can use a common factor of 6. If you use common factor of 6, 6 goes into negative 24. That would be negative 4, and 6 goes into 18 3 times. Now that's negative 4.3, so if we wanted to verify that, and we type in 0 here, and hit second trace 5 for the intersection, enter, 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 should be negative 1 1/3 repeating. Okay? So we verified that it does have the one solution. All right, I'm going to do number 4 as the last one, and make sure you can set up 5, and then I'm going to ask you to complete the rest for homework. So on this one, if you notice, guys, we're missing a linear term. If we want to consider that as a 0x term, that's fine. You don't have to write it. But A is -1, B is 0, and C is -4. If we type in 0 squared minus 4 times -1 times -4, let's see what happens with our discriminant value. So 0 squared minus 4 times -1 times -4. Oops, I'm sorry. It's not really going to matter, but -16. So that's what we're going to end up putting under the radical. And remember, because it's negative, we're going to have 2 imaginary. So by the way, let's go ahead and pause for a second and come back up here. We ended up getting D less than 0. So whenever we have a negative discriminant, we're going to have 2 imaginary roots. And when D equaled 0, we had 1 real root. Okay? So this is what you really need to know. Memorize your quadratic formula, and memorize that if your discriminant is positive, you have 2 real, negative, 2 imaginary, and if your discriminant equals 0, then it will be 1 real. So to finish this one up, because it's negative, we're going to have 2 imaginary. Okay? So x equals the opposite of b. Well, you can't really have the opposite of 0, but we'll go ahead and put that in there. Plus or minus the square root of -16 all over 2 times a. So what this means is 0 added to this stuff isn't going to change it, but you do still have to have the plus or minus. Keep in mind that we do have to have 2 imaginary roots, so we need that plus or minus. The square root of -16 is 4i over -2. And then go ahead and reduce that. 4 divided by 2 is 2. But if you divide the positive 4i by -2i, you get a negative. As in, 4i over -2 is -2i. And if you divide the -4i divided by -2, you also get 2i. So your answers really are just positive or negative 2i. So don't worry, whenever you have a plus or minus divided by a negative, technically I guess you can think of it like it changes it to, instead of plus and minus, minus plus, but it's the same thing as plus minus. So you get positive and negative 2, oh, sorry, I forgot my I. Okay, positive and negative 2i. To finish up, the only thing you really need to understand for the back is to make sure that you move terms over correctly so that it's set equal to 0. So I just want to make sure you get these right. And last one here. Again, I would, to be honest, move these terms over so that I keep the quadratic term positive. It just makes it easier so you don't have to simplify with the negative on the bottom later. So if I bring that over, that'll be minus 3x. If I subtract 7 over here, I get negative 11. All right, so you all should be good to go now to make sure that you finish the worksheet by finding your discriminant, stating the nature and number of roots, and then finding your solutions. Let me know if you have any questions by sending me a message.